To determine the correct breaker size for a 4500 watt water heater operating on a 208 volt single-phase panel, it is necessary to follow the guidelines established by the National Electrical Code, or NEC. The process involves calculating the full load current of the water heater and then applying a 125% factor to that current to determine the minimum ampacity of the overcurrent protection device, in this case, the circuit breaker. Let's begin by calculating the full load current. The formula for calculating current in a single-phase circuit is power divided by voltage. In this scenario, the power is 4500 watts and the voltage is 208 volts. Therefore, the full load current is equal to 4500 watts divided by 208 volts, which equals 21.64 amps. Next, we apply the 125% rule as mandated by the NEC for continuous loads, such as water heaters. This rule is in place to prevent nuisance tripping of the breaker due to the sustained high current draw of the appliance. To apply the 125% rule, we multiply the full load current by 1.25. So 21.64 amps multiplied by 1.25 equals 27.5 amps. This value, 27.5 amps, represents the minimum ampacity that the circuit breaker must be rated for. However, circuit breakers are available only in standard sizes. It is necessary to select the next standard size breaker that is equal to or greater than the calculated minimum ampacity. Standard breaker sizes typically include 15 amps, 20 amps, 25 amps, 30 amps, 35 amps, 40 amps, and so on. In this case, the next standard size breaker that is equal to or greater than 27.5 amps is a 30 amp breaker. Therefore, a 30 amp breaker is the appropriate size for a 4500 watt water heater operating on a 208 volt circuit. It's important to note that the inspector's suggestion of a 25 amp breaker is incorrect. A 25 amp breaker would be undersized for this application and could potentially lead to nuisance tripping or, in a worst case scenario, overheating of the circuit components. The NEC mandates the use of properly sized overcurrent protection devices to ensure the safety and proper operation of electrical equipment. Using an undersized breaker could compromise the safety of the installation and potentially create a fire hazard. Now, let's delve deeper into the relevant sections of the National Electrical Code that pertain to this situation. NEC Section 422.10, Appliance Overcurrent Protection, generally requires that appliances be protected against overcurrent. The specific requirements for water heaters are further clarified in other sections. NEC Section 422.13, Storage Type Water Heaters, addresses the branch circuit sizing and protection for storage type water heaters. It directs you to size the branch circuit conductors and overcurrent protection in accordance with Section 422.10, but also contains specific allowances and requirements. NEC Section 240.4, Protection of Conductors, specifies the requirements for overcurrent protection of conductors. In general, conductors must be protected at their ampacity, but there are exceptions for specific applications, such as motor circuits and appliance circuits. NEC Section 310.15, Ampacity of Conductors, details how to determine the ampacity of conductors based on their size, insulation type, and installation conditions. It is essential to select conductors with an ampacity equal to or greater than the calculated load current plus the 125% factor. So, in this case, the conductors must have an ampacity of at least 27.5 amps. Common conductor sizes and their approximate ampacities are as follows. Number 14 American wire gauge, or AWG, copper wire is typically rated for 15 amps. Number 12 AWG copper wire is typically rated for 20 amps. Number 10 AWG copper wire is typically rated for 30 amps. Number 8 AWG copper wire is typically rated for 40 amps. Based on these ampacities, number 10 AWG copper wire would be the minimum size conductor suitable for this application, as it has an ampacity of 30 amps, which is equal to or greater than the calculated minimum ampacity of 27.5 amps. However, it is always advisable to consult the specific ampacity tables in NEC section 310.15 to determine the correct conductor size based on the specific installation conditions. These tables take into account factors such as the insulation type of the conductor, the ambient temperature, and the number of conductors in a raceway or cable. It is also important to consider voltage drop when selecting conductor sizes, especially for long circuit runs. Excessive voltage drop can reduce the performance and efficiency of the water heater. The NEC provides guidelines for minimizing voltage drop in branch circuits and feeders. In addition to the conductor size and breaker size, it is also crucial to ensure that the wiring methods and materials used in the installation comply with the NEC requirements. For example, the wiring must be properly secured and supported, and the connections must be made using approved connectors. Grounding is another essential aspect of electrical safety. The water heater must be properly grounded to prevent electrical shock hazards. The grounding conductor must be sized in accordance with NEC section 250.122, which specifies the minimum size of equipment grounding conductors based on the rating of the overcurrent protection device. In this case, with a 30 amp breaker, the minimum size equipment grounding conductor would typically be number 10 AWG copper wire. It is also important to ensure that the grounding electrode system is properly installed and maintained. This system provides a path for fault current to flow back to the source, which helps to trip the breaker and to energize the circuit in the event of a ground fault. Common grounding electrodes include metal water pipes, ground rods, and concrete encased electrodes. The NEC provides detailed requirements for the installation and bonding of grounding electrodes. Finally, it is essential to remember that electrical work should only be performed by qualified and licensed electricians. These professionals have the knowledge, skills, and experience necessary to safely and properly install electrical equipment in accordance with the NEC and local codes. Working with electricity can be dangerous, and it is always best to leave it to the experts. In summary, to properly size the breaker for a 4,500 watt water heater operating on a 208 volt circuit, you must first calculate the full load current, which is 21.64 amps. Then apply the 125% rule, which results in a minimum ampacity of 27.5 amps. Select the next standard size breaker that is equal to or greater than 27.5 amps, which is a 30 amp breaker. Ensure that the conductors are sized appropriately for the load and the installation conditions, and that the wiring methods and materials comply with the NEC requirement. Ground the water heater properly to prevent electrical shock hazards. And finally, always have electrical work performed by qualified and licensed electricians. By following these guidelines, you can ensure the safety and proper operation of your water heater. Now let's consider some additional factors that may influence the breaker sizing and conductor selection for a water heater installation. Firstly, if the water heater is located in a damp or wet location, such as a basement or crawl space, it is essential to use wiring methods and materials that are suitable for those conditions. For example, you may need to use a waterproof cable or conduit and fittings. Secondly, if the water heater is installed in a commercial or industrial setting, there may be additional requirements or restrictions imposed by local codes or regulations. It is always best to check with the local electrical inspector to ensure that your installation complies with all applicable codes and regulations. Thirdly, if the water heater is part of a larger electrical system, it is important to consider the overall load and the panel and the service. The panel and service must be sized to accommodate all of the loads that are connected to them, including the water heater. This may require performing a load calculation to determine the total demand on the electrical system. Fourthly, if you are replacing an existing water heater, it is important to inspect the existing wiring and components to ensure that they are in good condition and are suitable for the new water heater. If the existing wiring is damaged or undersized, it should be replaced. Fifthly, if you are installing a new circuit for the water heater, it is important to consider the location of the panel and the route of the wiring. The wiring should be installed in a neat and workmanlike manner and should be protected from physical damage. Finally, it is important to keep accurate records of all electrical work that is performed. These records should include the date of the work, the name of the electrician who performed the work, and a description of the work that was performed. These records can be helpful for future maintenance and troubleshooting. In addition to the above factors, it is also important to be aware of the latest changes and updates to the National Electrical Code. The NEC is updated every 3 years, and it is essential to stay current with the latest requirements. You can purchase a copy of the NEC from the National Fire Protection Association, or NFPA, or you can access it online through various subscription services. The NFPA also offers training courses and certifications for electricians and other electrical professionals. These courses can help you stay up to date on the latest NEC requirements and best practices. Another valuable resource for electricians and electrical professionals is the International Association of Electrical Inspectors, or IE. The IE is a non-profit organization that provides education, training, and certification for electrical inspectors. The IE also publishes a variety of technical resources, including books, articles, and online forums. These resources can help you stay informed about the latest electrical codes and standards, and they can also provide valuable insights into the practical aspects of electrical installations. In conclusion, properly sizing the breaker and conductors for a water heater installation is a critical aspect of electrical safety. By following the guidelines outlined in the National Electrical Code, and by considering the additional factors discussed above, you can ensure that your water heater is installed safely and correctly. Remember to always consult with a qualified and licensed electrician before performing any electrical work. They have the expertise and experience necessary to ensure that your electrical system is safe and compliant with all applicable codes and regulations. Furthermore, consider the specific type of water heater you are installing. Tankless water heaters, for example, often have significantly different electrical requirements compared to traditional storage tank water heaters. Tankless models typically require a much higher amperage circuit due to their on-demand heating process. Always refer to the manufacturer's specifications for the water heater to determine the exact electrical requirements. These specifications will provide the correct voltage, amperage, and breaker size needed for safe and efficient operation. Ignoring these specifications can lead to dangerous situations, including electrical fires. Also, be mindful of the ambient temperature where the wiring is installed. High ambient temperatures can reduce the ampacity of conductors, requiring you to use a larger wire size to compensate. The NEC provides ampacity correction factors for various ambient temperatures. Always consult these tables to ensure that your wiring is adequately sized for the environment. Finally, when selecting a circuit breaker, choose a reputable brand that is listed by a recognized testing laboratory such as Underwriters Laboratories, or UL. This ensures that the breaker has been tested and certified to meet industry safety standards. Using a substandard or counterfeit breaker can compromise the safety of your electrical system. By paying attention to these details and adhering to the NEC guidelines, you can ensure a safe and reliable water heater installation. Remember that electrical safety is paramount, and it is always best to err on the side of caution.